So when the bulb is released, the liquid which is present in the horizontal pipe will come out as a fine droplets. Dynamic lift is nothing but the force that acts on a body such as aeroplane wings and spinning ball by virtue of its motion through a fluid. According to Bernoulli's principle, the air pressure above the ball is higher than the air pressure below the ball. Hello everyone, welcome to session 4 of chapter 10 Mechanical Properties of Fluids. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the last session we were discussing about Bernoulli's theorem and applications of Bernoulli's principle. Bernoulli's principle states that for an incompressible non-viscous fluid, the sum of pressure energy, potential energy per unit volume and kinetic energy per unit volume remains constant. In the last session, we have discussed about the expression also for Bernoulli's principle. And even we have discussed about the Torricelli's law, that is the speed of efflux, which is given by V is equal to root of 2gh. So in today's session, we are going to discuss about the applications of Bernoulli's principle. So where this Bernoulli's principle is applied, what are the practical uses of this Bernoulli's principle. In Pascal's law applications, we have seen that it is applied in hydraulic lifts, which is helpful in lifting the heavy loads such as automobiles and also hydraulic brakes. Similarly, Bernoulli's principle also have an impact or the practical applications in our daily life. Now, let us know some of the illustrations of Bernoulli's principle. So, one of the major application where we can say that the Bernoulli's principle is applied is the atomizer or sprayer. Sprayers are all very much familiar to all of us. We have all come across this in our daily life. Now let us say, how does the sprayers will work with respect to Bernoulli's principle? Yes, see here we have considered a liquid which is contained in a container. Here we can observe one vertical tube, one horizontal tube, and we have a fine nozzle here which will give us a tiny fine droplets of the liquid or the fluid which is stored in the container, and it is also given with a rubber bulb where we can squeeze it to increase or decrease the pressure. So sprayers generally will be having the pump or the bulb or the rubber bulb to squeeze it, which results in the outcome of fine or tiny droplets of fluid. Let us now study about this in detail. So we have atomizer or sprayer. We have all seen this in our daily life. So what is atomizer or sprayer? It's a device which is used to spray paints or perfumes or any liquids. So it consists of a small tank and also a rubber bulb, a horizontal pipe with a nozzle and also a vertical pipe. What happens if we squeeze the bulb? If the bulb is squeezed, the air blowing through the horizontal pipe decreases the pressure at this point, which means it decreases the pressure near the nozzle of the vertical pipe in according to Bernoulli's principle. If this is squeezed, here the air blows in a horizontal pipe, which results in the decrease in pressure in the vertical pipe, the nozzle. Because of this decrease in pressure, the liquid which is present inside the tank will raise up. Since there is a difference in the pressure, the liquid raises up in the vertical column. So when the bulb is released, the liquid which is present in the horizontal pipe will come out as a fine droplets. See, Bernoulli's principle doesn't only say about the sum of pressure plus kinetic energy per unit volume, potential energy per unit volume remains constant. It also says that the relation between pressure and the velocity, which means the pressure and velocity are inversely proportional to each other. Here if the pressure decreases, the liquid raises up, it will rush up, the velocity will be more, and when the squeezed bulb is released, the liquid will come out. So that is what the mechanism of atomizers or sprayers, in accordance to Bernoulli's theorem. Since the pressure inside the tank is more and the pressure outside is less, the liquid will be pushed up in the vertical pipe and split into tiny droplets by the jet of the air. So here when the ball is squeezed, the pressure here will be more and here will be less. Due to this pressure difference, the liquid will raise up in the vertical pipe and it will come out as a tiny droplets by the jet of air. This will give a fine spray of the liquid. So this is the mechanism of the sprayer or atomizer in accordance to Bernoulli's principle. Next we have dynamic lift. Another illustration of Bernoulli's theorem, that is dynamic lift. What is the meaning of dynamic lift? Why it is called so? Dynamic lift is nothing but the force that acts on a body such as aeroplane wings and spinning ball by virtue of its motion through a fluid. Aeroplane will also move in air and the spinning ball will also move in the air. Air is nothing but a fluid. Here dynamic lift is nothing but the force that acts on a moving body such as aeroplane wings, spinning ball that moves in a fluid. So let us now study about this in detail. So here look at this picture. So how does this aircraft moves higher, or how does it take off? What is the reason for it to take off? What is the role of pressure and the velocity of air in the movement of the heavy bodies like aircraft in air? What is the design of this aircraft wing? Why it is particularly designed so? So for all these curiosities, the answer can be given with the help of mechanical properties of fluids. Here there is a small attempt to understand the basic principle between the flow of air and also the result of pressure in lifting the aeroplane from ground to the higher level. So let us know about aircraft wing. So aircraft wing or airfoil design generally will be like this. See, when the aircraft is moving, the curvature of the air wing is different and it is not same in the upper surface as well as in the lower surface. Here there will be a difference in velocity of air which is moving in the upper surface and also lower surface, and if the velocity is more, pressure will be less. If the velocity is less, pressure will be more according to Bernoulli's theorem, because it also says that pressure and velocity are inversely proportional to each other. So we have to understand what is the motion of air, whether it is higher or lesser at the upper surface or whether it is higher or lesser at the lower surface. Generally, we can understand that to lift the aircraft, the pressure at the bottom surface must be more. If there is a pressure, it will pushes the object to the higher surface. So the pressure must be high at the lower surface, which means the velocity of air is lesser at the lower surface, but it is higher at the upper surface. This is the basic understanding. So let us study about this. According to Bernoulli's principle, as I told, pressure of any fluid decreases with increase in speed, which means pressure and velocity or pressure and speed are inversely proportional to each other according to Bernoulli's principle. So this fact is used in designing the aircraft wings. There is a greater application or practical application of Bernoulli's principle in designing the aircraft wing, because it says that pressure and speed are inversely proportional to each other. The curvature of the upper surface is more than the curvature of the lower surface. As I have shown here, the curvature of the upper surface is more when compared to the curvature of lower surface. As the aircraft moves in the runway with a very high velocity, the air blows over and below the wing. As the aircraft or the object moves on the runway with a higher velocity, obviously air flows in the upper surface as well as in the lower surface like this. But what is the difference? The air travels a long distance on the upper surface when compared to the lower surface in the same interval. At particular interval of time, the air travels to the long distance in the upper surface when you compare to the lower surface. The velocity of air above the wing is much higher compared to the velocity of air below the wing. As I explained you earlier, the pressure must be high here, which means the velocity will be less when compared to this region. So, because the aircraft also designed like this, the velocity of air moving at the upper surface will be more when compared to the velocity of air moving at the bottom surface of the wing. So according to Bernoulli's principle, the pressure above the wing is low because it is saying that the velocity of the air moving at the upper surface of the air wing is higher and hence the pressure will be low. Since the velocity of air moving at the lower surface is less, the pressure is very high. So below the wing, the pressure is very high and therefore an aircraft lifts up easily. Since the pressure here is very high, it helps in lifting the aircraft to the higher position. So this is the application of Bernoulli's principle in designing the wings of aircraft. So there is one more interesting application of Bernoulli's principle in understanding the spinning of ball. We all know how a ball spins. When the ball is spinning, it carries air along with it. So when the ball is spinning, it doesn't take a parabolic path, and we have also observed that a spinning ball doesn't take a parabolic path when you compare to the ball which is moving without spin. So let us now understand what is the significance of Bernoulli's principle in spinning ball. When a ball spins, it carries with itself a layer of air as shown in the figure. While it's spinning, it will carry the layer of air along with it. So when the ball moves forward, the air related to the ball rushes in the opposite direction. When the ball is moving forward direction, the air will move in the opposite direction. The ball is carrying will move in the opposite direction, and thus there is a decrease in the relative velocity, and hence the velocity of ball decreases. Why it decreases? Because the ball will move in the direction when it is spinning, the air which is related with the ball will move in the opposite direction, which results in decrease in the relative velocity. The layers of air below the ball moves in the same direction of the spin. So what are the layers which are present here in the lower surface of the ball? They will move in the same direction of the ball spinning, and thus their resultant velocity increases. So the resultant velocity will decrease when the air is moving in the opposite direction, since the air which is related with the ball at the lower surface will move in the same direction of the spinning ball. The resultant velocity of ball increases. Now, how is it related with Bernoulli's principle? Bernoulli's principle states that the relation between pressure and velocity, and this is how we can relate the spinning of ball with Bernoulli's principle. According to Bernoulli's principle, the air pressure above the ball is higher than the air pressure below the ball. So here, when the ball is spinning, the pressure above the ball is higher than the pressure below the ball, and due to this pressure difference, the ball feels a net force which deviates its path. Because of this difference in pressure, the ball feels a difference in or deviates its path. This is the reason why spinning ball doesn't follow parabolic path. Why the spinning ball will not follow parabolic path? Because the difference in pressure creates the deviation in the path of a ball. Why there is a difference in pressure? Because the ball feels a higher pressure in the upper surface when it is moving when you compared with the pressure at the bottom surface. Because of this difference in pressure, the ball will deviate its path, and this is the reason why it doesn't follow a parabolic path. Next, very important concept, that is Venturi meter according to exam point of view. One important question will be asked from this concept, that is, mention the device that works on the principle of Bernoulli's theorem, and the answer is Venturi meter. Or the question may be asked like this also: what is the principle on which the Venturi meter works? The answer must be Bernoulli's principle. Now, what is Venturi meter then? It is nothing but a device which is used to measure the flow speed of incompressible fluid. The device which is used to measure the speed or the flow speed of incompressible fluid is called as Venturi meter, and this works on the principle of Bernoulli's theorem. Now, generally this is how it looks. This is a typical diagram of Venturi meter. So, it works on the principle of Bernoulli's theorem. So, next is blood flow or heart attack. the blood flow or heart attack can also be explained with the help of Bernoulli's principle. You can observe here how it is explained with the help of Bernoulli's principle. If the artery is constricted due to the accumulation of plaque on its inner walls, then the area of cross section decreases. You can see here, if the artery is constricted or blocked with the accumulation of the unwanted things such as plaque, the cross-sectional area decreases. You can observe here, the cross-sectional area of the artery can decrease, which in turn increase the velocity of blood. So if this area increases, the flow of blood, which will try to rush in this region, because there will be a less cross-sectional area and the blood forcefully rushes into it, and the increase in velocity decreases the pressure according to Bernoulli's theorem. So since it rushes, the velocity of the blood flow will be more. Since there is an increase in velocity, there will be a decrease in pressure according to Bernoulli's principle. As the pressure inside the artery decreases, it may collapse due to the excess external pressure. Since the pressure inside the artery decreases, the excess outside pressure will be more and it causes the collapse, and the blood rushes through the opening. The internal pressure once again drops due to the same reason. So as this area of cross section decreases, the same thing, the blood start rushing inside it, and hence the velocity increases, the pressure decreases due to the same reason again and again. So because of this repeated collapse, the heart may get attack, or this results in the heart attack of a person. It is so simple that Bernoulli's principle is nothing but, it is so simple that Bernoulli's principle states that the pressure and velocity are inversely proportional to each other. Since the cross-sectional area of the artery decreases, the blood rushes inside it, which means there will be an increase in velocity. Increase in velocity results in decrease in pressure inside the artery. And as this repeats again and again, the heart will undergo collapse. Since the multiple or repeated collapse, because of this continuous decrease in pressure, there will be a repeated collapse inside the heart, and this causes heart attack. So this can also help in understanding the heart attack or blood flow. These are few illustrations of Bernoulli's principle, and in the study of mechanical properties of fluids, we will study about some more interesting concepts in the upcoming sessions. Until then, take care all of you. Thank you.